In this video, we are going to introduce the unit impulse signal in discrete time and explain all of its properties. The unit impulse signal is shown as in the figure below. It has a value of 1 only at the moment when n equals 0, and its value is 0 at all other time indices. Now, if the impulse is shifted by an amount n0, meaning we have delta n minus n0. For example, if n0 is equal to 3, then the unit impulse signal will have a value only at the moment when equals 3, and it will be 0 everywhere else. It will not have a value at n equals 0 anymore. As shown in the figure below, this corresponds to delta n minus 3. The next property is the sampling property, which states that when any signal is multiplied by the impulse, only the value of the signal at 0 matters. Therefore, xn multiplied by delta n becomes x at 0 multiplied by delta n. Similarly, if xn is multiplied by delta n minus n0, the result will be x at n0 multiplied by delta n minus n0. The next property is that the convolution of any signal with the unit impulse results in the same signal. Also, the convolution of any signal with a shifted unit impulse gives the same signal but shifted by the same amount. Another important property is that the Fourier transform of the unit impulse signal is equal to 1. If you pay attention, the unit impulse signal has a value only at n equals 0, but its Fourier transform has a value at all frequencies, and that value is 1. We can also represent this in the frequency domain as shown. The next point is that any signal xn can be written as a summation of xk multiplied by delta n minus k. For example, if we consider the signal xn as shown, at n equals 0, the signal value is 2, which we denote as x at 0 equals 2. At n equals 1, we have x1 equals 1. At n equals minus 1, we have x equals minus 1. At n equals minus 2, x at minus 2 equals minus 3. Now we can substitute these values. Since the signal exists from n equals minus 2 to n equals 1, the summation is written from minus 2 to 1. After substitution, we obtain terms such as x at minus 2 multiplied by delta n plus 2, x at minus 1 multiplied by delta n plus 1, and so on. Now we can replace the numerical values of x at those specific time indices and finally write the signal xn as follows. In this video, we tried to cover all the important points related to the unit impulse signal. We have also discussed the properties of the continuous time impulse signal in previous videos on this channel. If you are interested, you can follow our channel and watch those videos as well.